not a super technical talk. It's not talking about tons of different tools. There are plenty of talks out there that are great. You wouldn't be able to use most of the tools that we use at Google internally anyway, and they often don't make much sense at a much smaller organization. However, a lot of the organizational principles can be reused or adapted to other organizations and companies. And I think they are much more critical than the actual technology that you're using to implement them. It's not about just like setting up a program and mandating that everything now has to be DevOps or SRE and cloud and agile and all of that. It actually has to be from the bottom up integral to the culture, because as you all know, culture eats policy for breakfast. So how do you get there? How do you establish that culture? Let me say a few words about myself. I am a site reliability engineering manager at Google in Munich. Right now, I'm not in Munich because our office is closed, like probably most of your folks' offices. Before, I've been at Google for 5.5 years now, roughly. Before that, I was mostly in researching reliable distributed systems, but I've also worked as a developer in the industry, also as a sysadmin, crawling on the desk, plugging in cables, getting computers fixed, all of that. I draw a lot from these diverse backgrounds because they are all extremely important for that role. You can't just be like a sysadmin purely and then like be able to talk to developers and really understand what their problems are. It's helpful to have some shared perspective. My current role at Google is I'm the Uber tech lead for a group that we call SRE Engagements. We provide the programs and tools to build successful partnerships between SRE and developers, which we call engagements. That means throughout the life cycle of a product, we look at the production side of things. We standardize how these things get run, the technology, the processes. We look at success metrics. We really want to get a data-driven decision whether the product is running well or not, and have a proactive risk management strategy. We call that production excellence. We have a set of metrics that we evaluate and then discuss with teams to try to understand where they can do better. And we also drive large-scale change management. Looking at the size and age that Google has now, things keep evolving rapidly, and you need to move things with you, or otherwise you will just accrue technical debt, and that will slow you down. I also have still operational responsibilities, so every once in a while I'm on call for some of our cloud products like GCR, the container registry, and others that you might have heard about. Now, what is site reliability engineering? It's kind of a weird name. It's kind of like Google's implementation of DevOps, only that it's much older than the DevOps movement, because Google was already struggling with the challenges that DevOps tries to solve much earlier than most other companies. So SRE was started in 2003. Now, the key word in SRE is reliability. Also engineering site thing is kind of an artifact because originally it was about keeping the site, google.com, up, but it has evolved much more since then, and it's now more like service reliability engineering if you want. But why do we care about reliability? It's very easy to demonstrate. It's the #1 feature. It's either you have that or you don't even play the game. Let me show you why. Imagine the following product: Gmail 2010. Off-the-shelf web mailer. 10 years later, it looks a bit old-fashioned. It lacks a ton of features that any product manager would tell you are essential. the search is not good, it doesn't have smart compose and autocorrect and like all the fancy features. It's not even following the UX design that Google now wants it nowadays, so our UX designers would freak out. So this isn't really the product that you want. But how does this product compare? Would you rather have that product or the alternative that I call Gmail 500? So, I mean, imagine the Gmail 500, the 500 temporary error screen to be fancy, modern, with all the used frameworks and UX design. It's still useless for the user. All the greatest features that you have are futile if your users can't use them. So the first, most important feature is that your system is reliable, that the users can use it. Now, the problem with reliability is it's the absence of errors. It means nothing is broken. However, once it is broken, it's kind of hard to get back to a reliable state because to get there that the system is utterly broken, it's not just down like now and you fix it and then it runs stable for the next few weeks, but it's like it breaks all the time. Not a single thing has gone wrong. Many things have gone wrong and have like accumulated to this big hairball of problems. And to unwind that and get back to a healthy state, that takes a lot of time. And in that time, you won't like launch all these crazy new features that will make the world a better place, will drive your revenue up and make your competitors unhappy, drive them to heavy drinking and out of business, and then eventually apply for a job at your company. But you want to launch these features. You don't want to focus on reliability solely. And that is why you need to be proactive about it. And that's very hard because it's the absence of errors. It's a bit like oxygen. Oxygen is all around us. We take it for granted until we don't have it. And then we realize how essential it is. But then it's often too late to act. So you need someone to work on reliability all the time, not just reactively, but proactively. The official motto of SRE at Google is hope is not a strategy. You need something better than that as your strategy. So that is why we have a separate organization as SRE. SREs are not part of the developer organization. It's a separate organization reporting up to our own VPs. And we support the dev organization. They give us the job, the mission, and then we help them with that. So we actually always have someone at the table who says, we need to talk about reliability. Now, that sounds a little bit like a good old ops team that says, all we care about is that production is running. You take care about development, we take care about production. And if you have been in a business for a while, you know that these devs teams and these ops teams basically always fight. And that's not very surprising because the incentives, the underlying incentive structure is very different for them. If you're on a dev team, you want to launch these cool new features, you know, about the competition and all of that, and make the world a better place, or at least get yourself promoted. And you don't care much about anything else. On the other hand, on the ops side, the only thing that you care about is that the system doesn't blow up on your watch. Not on anyone else's watch, but specifically not at yours at 3 a.m. in the night. So you want to keep this pager silent, no matter what the cost. Now, what is the number one reason for systems breaking? Anyone, any suggestion?
Networking issues.
Say again?
Networking issues.
You should get a better network provider.
A new release, a deployment.
New changes.
Change is what breaks systems. So
we also have deployment and human error.
Devs want change and ops wants no change. So here we have a conflict of interests. So how do we resolve that? The classic way is you make reviews. Every single thing that gets deployed to production, every release, every change needs to go through a review process where the ops team looks at that. You have to go through checklists and then say, yeah, I've done that, I've done this. And also, because that's not really enough, you need to do a code deep dive, or you need the ops team as code reviewers or crazy stuff. But at the end of the day, really, that doesn't help because nobody understands the system better than the dev team. And the ops team will always play catch up. And I mean, if the ops team say you can't do a new feature release, well, then it's a bug fix, right? It's a low risk flag flip. So this is an arms race and it leads nowhere. So how do we stop this? We're not even trying that at Google. We don't try to be the gatekeeper of production as SRE. We don't want to eliminate launch risk. We don't want to set a concrete release policy that everyone has to follow and go through all these checklists, or to avoid all outages in the first place. We accept that there will be outages. Now you might wonder how Google is still in business. It's a bit more complicated than that. It's not like we say, whatever, things will break, I don't care. Let's drink some tea. But we do have a rule. And that rule is called error budgets. Let me explain that in a second, but first we need to talk about SLOs. SLOs are service level objectives. Basically, you have an SLI, an indicator that tracks a metric of the system, like availability, response time, throughput, data freshness, data durability, whatever. Any metric that tracks the quality of the service that you're providing. And that is to be decided for the product that we're talking about. There's no generic set of metrics and targets. And the service level objective, the SLO, that's a specific target where you say, I need an availability of 99.9%, for example. And an SLA, and it's often confused with SLOs, but in our terminology, an SLA is basically a contract that says, these are the SLOs that our service has, and here are the consequences if we don't meet them. It's kind of a contract between the provider and the user. The user can be a customer, and the consequence could be get your money back. It could but also be something internal that says okay, if the system breaks, we will respond within 30 minutes and work on it, or it will be our P0 priority for the rest of the quarter to get this fixed, or whatever. I don't want to talk too much about SLAs, but SLOs are really, really important thing. And the question is, how do you set them? Does anyone know what this is, what we're looking at here? It's a pacemaker. And if I ever should need one, I will not settle for the one with 3 nines of availability or 4 nines. It's 99.99%. I actually want to get as many nines as possible. 100% if possible. I don't think that's really realistic because it's electric mechanical thingy, but as close as possible. And I'm happy to pay a premium for that. Do you think the same is true for software systems? Well, I kind of gave it away. It's not. And the reason why it's not is because actually, if you provide a service through the internet, people will interact with it through their home internet, through their end user device. And neither of that has an availability of close to 100% either. If my home internet connection has like 99.5% of availability, I'm very happy. If you pull your phone out of your pocket and it works more than 99 out of 100 times, that would be great. And that's true for phones of any manufacturer. I mean, there's so many things that can go wrong, the internet connection, the battery, the software, whatever. But at the end of the day, for the user, it doesn't really matter why they get an error page or why the thing isn't working at all. It's just, it's not working. So if your error rate is 10 times better than the underlying noise, nobody will care. And optimizing it further will not get you any more user trust, but it will cost you a lot. Any reduction, adding any 9 to your availability, and the same is true for latency, and even for latency there are even harder limits because of the speed of light, is getting more and more expensive. And it's not linear, it's exponential. And so you have to make a trade-off. What is the right trade-off? That really depends on your product. It's not actually a decision that SRE or DevOps or Ops should do, or the developers either. That's actually a product management decision. Like, what is the trade-off that we want? What is the mix between reliability and features that you want? If you're controlling a nuclear reactor, you could probably drop a few features as long as the reliability is good. If you're sending funny animated pictures of the internet, probably having a few more funny features is more important than the thing working not every once in a while. Now, if you take that SLO and say you have 3 nines, that means that you can have 0.1% of errors that are okay, nobody cares. That's how you define your SLO. That is the availability that makes your users happy. And it is a budget that you can spend. Imagine a service with, say, 1 billion queries per month. 0.1%, that's 1 million errors. And you can spend these errors. Now you have multiple options on what to spend them on. You could spend them, for example, on changes, doing like risky launches with fancy new features very, very quickly. Or it could be just that your system has problems all day long. The database server is like crashing every once in a while and kills a few queries, and you accumulate errors. The problem is, at the end of the day, if your budget is spent, you're not launching anymore. Every time you want to deploy a new thing, you look at your error budget. As long as you still have error budget, you can launch whatever you want. As long as you're not meeting your SLOs, you don't launch anything that isn't a bug fix to get the system more stable. It's a very simple rule, and the beauty of it is it removes this subjective conflict, this conflict of interest, by agreeing on like what is the trade-off that we're trying to achieve, measuring it objectively, and then looking at it and agreeing like, what do you want? And then if you see it's red, it's not a problem for one side. It's a problem that both sides share and that both sides work on together to resolve, because the dev team really, really wants to get the system stable again so they can launch their features. And actually, they will change the culture in the dev team. They will start caring about what their colleagues do, because if they break the system, then you can't launch your feature next week that you want to get promoted for and buy the new car or whatever. So that is a very, very strong tool because you change the incentives. However, there's a catch. There's one way that you can still meet your SLOs without caring too much to build a stable system. And that is by throwing people into the grinder. I mean, you can basically add more people to the ops team, crunching through the ticket queue, finding ways how to get the system back up and running again, and shouting at them all day long. And then you can launch all your features. That's not really a fun job for those people, and that's not really a job that I would like to do, and not a job that I ask anyone on my team to do, nor am I asked to do it. But how do we avoid this problem? The problem here is that, like, developers are not bad people. I've been a bad developer myself. You're just trying to get your job done, and then it's very easy to forget that there are other people and how your actions or non-actions do affect them. The problem is you don't have any incentive to, like, remembering that building a shitty system will mean a lot of work for other people. So we have 6 different ways to fix this problem. The one is a common staffing pool. When you want someone in the SRE team, you have to give the headcount to SRE. That means 1 developer less in your dev org. So imagine your dev organization gets 10 new positions this year to grow, and then you can decide whether you, like, take 9 of these to develop new features and 1 more to keep that system running, or you throw 9 of them at just operations and only 1 person to develop new features. And now it's a simple optimization problem, and the dev team will very quickly figure out how much of their dev time they need to dedicate to make the system more stable, to minimize how much of the work that they give, the headcount they give to SRE to fix that. And then you can minimize both to have the overall cost low and maximize the feature velocity. Now you might say, wait a second, now you reducing the positions, the headcount that your team is getting. Yes, and it's working as intentional, working as intended. Actually, the work that we will be left with is the really challenging and interesting work, the engineering work, to make the system really, really better, and not just, like, working through tickets that are, like, brain dead. Now, the second thing is we need to make sure that the dev team and the SRE team are speaking a common language, that they understand each other, they understand each other's problems. And that is why everyone that we hire in SRE at Google has to have some coding background. They don't need to have a master's degree in computer science or need to be a full-blown developer, but they need to do non-trivial coding so they are able to speak the same language as the devs. And actually, a lot of the SREs at Google meet the hiring bar for a developer. They could actually switch to developer role without any coding interviews, including myself. But there's another advantage for hiring coders, and that is, if you're a coder yourself, you probably know that coders get bored very easily. So you get a bug the first time, and you're like, huh, this ticket, I've never seen that before. That looks interesting. Let me figure out how this works. Then you get it a second time, and you're like, oh, is it the same thing? Let me try this out. And it's like, ah, yes, I found a pattern. Great. And then you get another 10 of those, and you're like, oh, no. This is really, really annoying. Let me write a little shell script to automate myself out of the job. And this is exactly the behavior that we want, because that means that you can scale your system with automation instead of with people. Automation has other advantages. For example, it makes stuff repeatable, so you have less human error. Number 3. We have a 50% cap on ops work. The SRE team on the long term should not work more than 50% on operational stuff, what we call toil. In practice, it's much lower, like most teams have less than 30%. Most teams that I've worked on have more like 10 to 20% of their time dedicated to anything that's operational. All the other things are project work. It's automating things, it's improving the systems, it's reviewing the system, it's building infrastructure, it's making things better. And you need that to be able to scale with the system, with the new features coming in, with the new traffic coming in. As the system grows, you need to be prepared, or otherwise you're in a downward spiral and you will drown and you will fail. Except if your system doesn't grow. But you know, in this business, if your system doesn't grow, it means you will likely be out of business very soon. So you have to be prepared and you have to be able to scale. Number 4, we do keep the developers in the on-call rotation. They will have production responsibility. So they are aware of the problems that their code is causing, and they can take that into account as they keep developing. And that builds a shared understanding. As much as the SREs need to understand code, the devs need to understand production. It's not something that you can shield the dev team from. That is the DevOps mindset. Everyone needs to have at least a basic understanding. Even though the SREs are the specialists, the experts, the developers, the features developers need to understand this. Some teams push back on that, but it's really powerful, and you should like get all the executive support that you can get to push this through. And once they've done it for a while and they've seen the support that you give them, they love it. Number 5, you might have wondered, if we put a cap on ops work, what happens if the ops work is growing too big? Well, it's fairly easy, because we have the devs in the on-call rotation. As soon as the SRE team gets overwhelmed, the overflow goes to the dev team. And that is a very nice self-regulating systems, because the more time that the devs are spending on ops work, the less time they spend on writing new features that break more stuff. Number 6, SREs have the same mobility as any other engineer at Google. So if you don't want to stay on a team, if you don't enjoy that work, just look for an opening elsewhere in the company, and then you can typically go. And I, as a manager, I have no intention of keeping anyone on my team. I mean, there are certainly a lot of people that I would love to keep, but my main job is to enable their careers. So if you give a lot of shitty work to the SRE team, the people on that team will start to leave, and it will be very hard to find new people joining that team. So at some point, the team will just break down. There will be no more SRE team. And the dev team will be like, no, what happens now? Well, guess what? Here's the pager. Now you're on call. Now your problem, you have to deal with all the production problems yourself. It's a bit of a threat. It's the nuclear option. Nobody wants that. But as long as this is taken seriously and this happens, it has to be, it's not just on paper, this actually happens. Very, very rarely, but that is because everybody knows it can happen. So they're doing everything they can to avoid getting there. Because for the dev team, that typically means that they will be in a very, very bad place, struggling for the next few quarters, trying to get their grip on production. Their velocity will suck, and they will be left with a job that they don't really know how to do, because otherwise the system wouldn't have gotten there in the first place. So everyone joins forces very, very focused to avoid that situation. And that is really what we want. We want a good partnership where everybody is moving in the same direction. So single staffing pool, hire coders, cap on ops work, involve the devs and prod, did the overflow ops work to the dev team, and ensure mobility. Now let's talk a bit about actually being on call. As I said, we don't want 100% SLO typically. As long as there are no lives at stake, there's no real reason to maximize that ever. But that means there will be outages. That is expected, that is okay. It's not always fun. Nobody likes to get paged, but it's part of the job, and it's actually sometimes really valuable. Now, when we do have an outage, we want to minimize the impact. You can minimize the impact in 2 dimensions. The scope, like how much of your system goes down. That's an architecture question. And also the time scale. And then the other thing is you want to prevent this happening again. You want to make sure that every new outage is new and interesting, and you're not like working through the same problem over and over again if it can be avoided. So how do we get there? So minimizing the impact on the time scale means you have to make it as short as possible. The mean time to resolution has to be small. So we page the on-call in the SRE team or the dev team for that matter. Most people from the dev team also have some kind of on-call responsibility directly. There is no central hub, no knock that like routes tickets to people, because that would just add latency. We want the people to be able to act and be at their keyboard as quickly as possible. And then you want good diagnostic information. You want automated monitoring. That's the base level of everything. And that automated monitoring shouldn't say like error ratio high. That's not helpful. Packet loss between cluster A and cluster B being 5% as opposed to 0.1% usually. That is useful information that helps you to figure out what went wrong and how to fix it. And that really, really improves your reaction time for mitigating the outage. Another thing that's super critical is practice. So you need to have done that before to be really good. Studies have shown that this reduces the mitigation time by 70%. Now, if you ask a bunch of engineers to do an operational readiness drill, people will have like very important other work to do immediately, like filing their expense reports and updating the documentation and all this other high priority work that they're very eager to do. So we need something that is much more fun. We call this Wheel of Misfortune. It's basically a role-playing exercise where someone is the game master and sets up a scenario. Imagine it's 6 a.m. and you get paged, and the alert message says the following, blah, blah, blah. Now, what do you do? And then someone is the victim, the on-call, and they try to figure out what's happening, and the rest of the team can help out. They can loop them in, so they can even practice coordinated incident response and stuff like that. And it's a bit of a detective game and can be really fun, and it actually uncovers a lot of things that actually didn't go well, that people click on links in the documentation that are broken, and then you have immediately something to fix. And then you want to prevent recurrence. So first, the most important, the most urgent thing is get the system up and running with duct tape, whatever. Just make the users happy again as fast as possible. But it doesn't stop at that. Then you write a post-mortem, and the post-mortem is about root causing it, figuring out what has actually caused this problem, and then fix it. Now the post-mortem has to be blameless. Now, if we have a big red button that Christof pushed that took down the system, the question is not, why is Christof so stupid? But why do we have that button in the first place? We have to assume that everyone in the team is intelligent and well-intentioned. If the people in your org are not intelligent and well-intentioned, you have a much bigger problem that no policy or technology can ever fix. So make sure that you have intelligent and well-intentioned people and then treat them like that. So don't talk about blame in postmortems, focus on process and technology. And that will really help people to come forward and talk about everything that has gone wrong. Be very open about it, because they know they won't get fired. They won't get dinged in the next performance review or anything, or frowned upon by their colleagues. We cherish failure. We really want to know everything that wants to went wrong. Like war stories are the most popular thing among SREs because we learn from it. So post-mortem basically is a timeline, all the things that happened, all the facts, a deep analysis of what actually caused this, and then a list of action items of how do we prevent this? How do we mitigate this quicker and easier? How do we make sure it can't even happen again? And don't just like leave these action items in the post-mortem document, put them in your bug tracker so they actually get prioritized in your next sprint, and make sure that they have the appropriate priority and everyone understands how important these are. Because if you don't fix them now, they will show up in your next post-mortem. That's about it from my side. We talked about why reliability is important, that you need a dedicated team for that you need an SLO as the target, and that this is a trade-off between reliability and velocity, how to limit operational work, and how to do incident response in postmortems. You can read a lot more about that. We have published multiple books. I only have 2 hands, but there's a new one about building secure and reliable system that came out just like last month, I believe. And you can even read them online at google.com/SRE in a Creative Commons version. Thank you very much.